See this, we are supposed to solve the system of these equations. Now if you observe it, already unknowns are given as x, y, z, and now the quotient matrix, it actually depends on the values of k. The quotient matrix actually depends on a variable called k. So depending on the various assignments to the value k, we can think about how these solutions will be formed. So what the question is, you have to analyze what happens for all values of k, how does this matrices behave, how does this the solutions change. So okay, don't worry about this explanation, I'm not sure you understood it, but let's continue the example, you'll understand it by the end. Okay, now let's write it in the form of ax equal to 0, where a is quotient matrix as it is and x is the variable matrix x, y, z, ax equal to 0, right? And now just apply the echelon form and see what we get. So just to get it into echelon form, what I'm trying to do is I'll use the first element and I'll try to make all these elements as zeros. But then directly making it, you might have to multiply with 2 and then subtract it. Instead of avoiding that headache, what I'll do is I'll just swap these two rows, first row and second row, then I got it. Now using this first element, I can make the other elements as zeros, right? I can multiply this one with 2 and subtract from here. I can subtract this one from here. Then I can get these two values as zeros. These are the two operations I performed here. Now we got this. Now this is the quotient matrix we got. Now we know that if the determinant of this one is not equal to 0, then what does it mean? If the determinant of this one is not equal to 0, it is a 3 by 3 matrix, remember it. It is a 3 by 3 matrix and the determinant of a 3 by 3 matrix is not equal to 0, then the rank turns out to be 3. If the rank of the matrix is equal to 3 and the number of unknowns are equal to 3, then it will have a unique solution which is 0 solution, right? So what are the values for which this determinant will become, if it is determinant is not equal to 0, then we have a unique solution which is 0 solution. If the determinant is equal to 0, then what happens, that the rank is going to be less than 3, which is less than the number of variables, therefore it will have solutions, right? It will have infinite number of solutions. So we have to analyze these two cases. For that reason, I'm trying to find out the determinant of it and I'll equate it to 0. If I find out the determinant of this, I got this one. This is the determinant. I'll just try to equate it to 0. Why am I doing it? Whenever determinant is equal to 0, rank is less than 3, and so rank is less than number of variables, and so we have non-zero solution, right? So when determinant equal to 0, when I get determinant is equal to 0 is whenever k equal to plus or minus 2. If k is equal to plus or minus 2, then I can say that determinant equal to 0. Then what can I say? Then I can say that the system will have infinite number of solutions. What happens if k is not equal to plus or minus 2? If k is not equal to plus or minus 2, determinant is not going to be equal to 0, which means rank of the matrix is going to be 3, which is equal to number of variables, which means there will be unique solution. So we shall analyze all the cases. What happens if k is not equal to plus or minus 2, or what happens if k equal to 2, what happens if k equal to minus 2. We shall discuss all these cases. Now case number 1 is k is not equal to plus or minus 2. If k is not equal to plus or minus 2, then what happens? Then the given system of equations possesses only 0 solution. What could be the reason for this? Just now I told you, right? The determinant is not equal to 0, which means rank equal to 3, rank equal to number of unknowns. Whenever rank equal to number of unknowns, we can say that the number of there is only unique solution which is 0 solution. Got it? And case 2, assume that case 2 is when k equal to 2. When k equal to 2, we got this, right? So what can we say about it? You can clearly see that if I divide this one with 10 and if I divide this one with 4 and if I subtract it, this can be made 0. Therefore the number of non-zero rows will be 2. Therefore rank will be 2. When rank equal to 2, what can we say? Number of variables n equal to 3, unknowns n equal to 3 and rank equal to 2. Therefore what can we say? The number of linearly independent solutions will be n minus r, which is 1, which means one linearly independent solution is possible. only one linearly independent solution is possible, and how many variables have to be assigned random values? Only one. Therefore, we have one linearly independent solution, which means infinite number of solutions are possible, and we shall find what they are. I hope you are understanding this. See, simple method, don't get confused here. There is quotient matrix that is given. Now they are asking for all the values of k. Just analyze this. So what I am trying to do is I am just trying to see what happens if the determinant of this matrix is 0. If the determinant of this matrix is going to be 0, obviously we can say that the rank is less than 3. If it is not equal to 0, we can say that rank equal to 3. Then one case is the rank equal to 3. For that case, we have unique solution, which is 0, and the other case is rank is less than 3. When is that possible? Whenever k is plus or minus 2. For plus 2, I analyze this. Got it? And now I'll do one thing. I'll erase there and I'll continue this one. So what I'll try to do is, now we just found out that there is one linearly independent solution. I'll try to find out what that solution is, and next we can move on to the third case. Second case is over and the third case will be k equal to minus 2. Okay, fine. I'll erase it and I'll do it there. I'll continue it. Okay. Now let's continue this. Hey, in the earlier one, I did a small mistake. Here the k has to be minus 2. Okay, correct it. When k equal to minus 2, then if you substitute k equal to minus 2, this is what the equation we got. And then what I am trying to do is, see, here I have avoided one step just to cover this space. Multiply this one with 10, multiply this one with 4. Here it will become minus 1, 1, minus 1, 1. And you subtract from row 3 the row 2, then you get all zeros here. Got it? And then you can see that you'll get these equations. From here you'll get those equations. Therefore, this is the equivalent system of equations when k equal to minus 2. And we already know that the number of variables which have to be initialized to random value is 1. So I am assuming that, let me assume that z is the variable for which I am going to randomly assign a value c. And in terms of z, we have to express all the others. If you see this, y equal to z. Therefore, since z equal to c, y is also equal to c. Right? And if you see this, x equal to 2 into y minus 6z. So in place of x and z, y and z, you substitute c and c. Then you are going to get x equal to 4c. Therefore, this is a generic solution when k equal to minus 2. So are you understanding it? When k is not equal to plus or minus 2, there is a unique solution 0. When k equal to minus 2, we got this generic solution. What does it mean? It means that we can form infinite number of solutions. If you want to see what are all the infinite number of solutions, you can see it here. X, Y, Z. If you put all ones, it is going to be 4, 1, 1. If you put 2 equal c equal to 2, you are going to get 8, 2, 2. If you put c equal to 3, you are going to get 12, 3, 3, so on. Right? So we got infinite number of solutions. Now the next case is k equal to plus 2. What does it mean? Whenever you are going to substitute k equal to 2 in this one, what happens? We already know that there will be infinite number of solutions because the determinant is going to be 0 if k equal to plus 2. See this, k equal to plus 2, determinant of this one is already 0. Why? The reason is it is having rank is less than 3. Therefore, what can we say? We can say that rank of this one is 2. So what does it mean? If rank equal to 2, then how many linearly independent solutions will be there? See, first thing is rank is less than n, therefore infinite number of solutions will be possible. And how many linearly independent solutions will be there? N minus r, which is nothing but 1. So we have one linearly independent solution. And how many variables have to be, or how many unknowns have to be in random values? Only one variable. So I'm just writing, when k equal to 2, I'm just writing down what happens to the given set of equations. The given set of equations just gets transformed to this. So what is this? X plus 6y plus 10z equal to 0. Minus 6y minus 10z equal to 0. Right? Now from this you can derive that if I want to express everything in terms of z, why? Because one of the variables z is going to be assigned to a random number. If we choose z to be c, I want to write everything in terms of z. So you can see that y is written as if it is minus 5 by 3z, and x is written as x. If you substitute x, it is going to be 0. See this value is already 0, and this is nothing but the same value. Therefore what can we say? In terms of z, y equal to this much and x equal to this much. Okay, now if you substitute z equal to c, the solutions you get are this: 0, minus 5 by 3c, z equal to c. This is the generic solution when k equal to plus 2. So how many solutions will be there when k equal to plus 2? There will be infinite number of solutions. So how can they ask the question is, they will give you the equations as I gave you in the question, and then they will ask you what happens when k equal to 2, what happens when k equal to minus 2, what happens when k equal to 1, what happens. So when k equal to 1 means k is not equal to plus or minus 2, then only 0 solution, right? When k equal to 2, infinite number of solutions. When k equal to minus 2, infinite number of solutions. How many linearly independent solutions are there? Here 1, here 1, here 0. Got it? So linearly independent solutions here are 0. Linearly independent solutions here are 1. Y n minus r equal to 1. Here also 1. Y n minus r equal to 1. Therefore in the gate they might not ask you this entire question. They might just give you one bit like this one. And k equal to 2, analyze it. Then what should you do? Substitute k equal to 2 in the original equations and get the equation in normal ax equal to 0 form, like how we were doing till now. And then you solve all that using the echelon form, and you can directly get the answer. Understood this? I hope that you understood the explanation. Otherwise, please watch it once again. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.